What we're ultimately interested in is understanding the effects of policies or other changes in the environment on the equilibrium. So comparative statics allow us to make such comparisons. So they allow us to look at what happens before and after there's a change. So for example, if we wanted to understand the impact of the price of hogs on this pork market, we would be able to do the comparative statics with respect to that particular price of that particular input. So let's suppose the price of hogs increased from $1.50 to $1.75. What's the effect on equilibrium? Well, remember the original equilibrium price was $3.30, with consumers demanding 220 million kilograms of pork. But now the supply is only going to be 205 at the new supply function. Remember, when the price goes up from $1.50 to $1.75, that causes the supply curve to shift to the left, meaning that at any given price, the quantity supplied is going to be lower. So now, rather than 220 million kilograms, the supply is only going to be 205. So now the price is too low for the suppliers to provide the demanded quantity of pork. So if we want to equate supply and demand again, we could find the new equilibrium. So after this change, after we arrive at the new price for hogs, there's going to be a new equilibrium. And that new equilibrium, the price of pork is going to be $3.55 a kilo, and the quantity consumed is going to be 215 million kilograms. So what we see here is that an increase to the price of hogs causes an increase to the equilibrium price and a decrease to the equilibrium quantity. Now, this was a pretty substantial increase. That's a 25-cent increase. But we might want to know what happens if there are very small changes. And if we do that, if we do want to know what happens if there's very small changes, we might not need to actually calculate and then recalculate the equilibrium. So let's suppose the supply depends on some environmental variable A. Right? In our example, the environmental variable would be pH. Now let's say demand does not depend on A. So A doesn't enter into the demand function. Now the equilibrium prices, P, are going to solve the equation that whatever A is, the supply at the given prices, at the equilibrium prices, P, has to equal demand at those prices. Now, what that equilibrium price is going to be, such that supply and demand are equal, is going to depend on what A is. So depending on A, there's going to be some equilibrium price. In other words, the equilibrium price is a function of A. So let's call it P of A. So, for example, if we go back to the pork market that we looked at, A would be the price of hogs, and so we calculate the price of pork in equilibrium when the price of hogs is $1.50, and then we calculated the equilibrium price of pork when the price of hogs is $1.75. So in this way, the price of pork is a function of the price of hogs. So really what the equilibrium condition is this equation. At every possible price of hogs A, the supply of pork has to equal the demand of pork. Of course, the supply of pork is a function of both the price of pork, which depends on the price of hogs, as well as the price of hogs. And the demand for pork depends only on the price of pork. Abstracting away what A is, just for any arbitrary environmental variable A, the equilibrium price when that environmental variable is A is such that the supply at that price equals the demand at that price, given that environmental variable A. Writing it down this way, we can use calculus then to understand how the equilibrium price is going to depend on A. So let's take the derivative of this equation with respect to A on both sides. So let's actually write down the equation up here. Okay, so we've got this equation, S of P of A equals D of P of A. Now, don't be scared by the calculus. I'm not going to ask you to reproduce this type of thing. You're not really going to have to get into the weeds on this, but we'll work through it together here just so we understand what's going on, but don't be too worried about this. So let's start with the right side because it's easier. This is just straight chain rule, right? We've got D of P of A. So the derivative of that with respect to A is just the derivative of D with respect to P times the derivative of P with respect to A. Okay, now let's look at the left side. A appears in both arguments, the first and the second argument. So for the first argument, we take the partial derivative with respect to the first argument, which is the price. So we apply the chain rule. So we get the partial derivative of supply with respect to price times the derivative of price with respect to A plus the partial derivative of supply with respect to A. So that's the total derivative of the left side with respect to A. So those two have to be equal to one another. So if we rearrange that, we can solve for the thing that we're interested in, dPdA, because this tells us how P responds to A. So rearranging the equation on the first line, we find that dPdA is just the ratio of the partial derivative of supply with respect to A to the difference between the derivatives of demand and supply with respect to price. Now remember, law of demand says the demand curve is sloping downward, so the derivative of demand with respect to price is negative. Also, the supply curve is typically sloping upwards. So let's suppose that it's sloping upwards. Remember, we don't have a law of supply, so we don't know that it's always sloping upwards, but it typically is. So let's suppose delta S, delta P is positive because the supply curve were sloping upwards. Then what this tells us is that dPdA, so the way in which the price responds to A, is the opposite of the way supply responds to A. So these two things have to have the opposite sign. So if supply increases when A increases, that means that price decreases when A increases. Conversely, if supply decreases when A increases, then the price is going to increase when A increases. And then if we want to understand how the quantity responds to A, we can just take the derivative of this thing. Remember, the quantity in equilibrium is just the quantity demanded at the equilibrium price. Take the derivative with respect to P. Remember, that's just the right-hand side of this equation. So we look at dP dA times derivative of demand with respect to P, and we see that that's equal to dQ dA. So quantity responds to A in the opposite way that price responds to A, because demand has a negative derivative with respect to P. So this derivative and this derivative have opposite signs. So if P is increasing in A, then Q is decreasing in A. Conversely, if P is decreasing in A, Q is increasing in A. Now, how big are these changes? This only told us about the signs, but what are the magnitudes? Because we would really want to know how big are these changes. So let's suppose the supply curve shifts to the left. Then we're going to shift from this equilibrium to this equilibrium. So the quantity goes down, price goes up. The steeper the demand curve, the smaller the change in quantity. See, if the demand curve is vertical, there's no change in quantity. The flatter the demand curve, the bigger the change in quantity. How demand responds to a change in price depends on its elasticity. Now, the law of demand says that it's going to be decreasing, but the elasticity gives us a very nice summary of exactly by how much.